Welcome to today's lesson presentation on floating and singing, a Form 4 topic, and the questions that we wish to revise today include question 1, which reads, the figure below shows a rectangular block tethered to the seabed by a wire. The block is of dimension 4 meters by 3 meters by 2 meters. If the density of the material making the block is 0.167 grams per cubic centimeters and the density of sea water is 1.1 grams per cubic centimeters, calculate Roman 1 the upthrust force on the block. For us to be able to solve this question, we must have an understanding of the Archimedes principle. How does Archimedes principle state? It states that when a body is partially or fully immersed in a fluid, it experiences an upthrust force equal to the weight of the fluid displaced. In simpler terms, the Archimedes principle says that the weight of the fluid that an object or a body displaces equals an upward force on that object immersed in that fluid. Therefore, for Roman 1, for us to be able to calculate the upthrust on the block, we shall be required to determine first the volume of the seawater that will be displaced by the block. We have been given the dimensions as 4 meters by 3 meters by 2 meters. Therefore, the volume of the seawater displaced by the block will be 4 meters times 3 meters times 2 meters. That gives us 24 cubic meters. We have also been given the density of the seawater as 1.1 grams per cubic centimeters. We express this density in its SI unit, which gives us 1,100 kilograms per cubic meter. That means we multiply the given quantity by 1,000. So using the volume and the density, we find the mass of the seawater displaced by multiplying the volume of water displaced times the density of the seawater. So that means 24 cubic meters times 1,100. From there, we need to find the weight of the seawater displaced. And weight is given by mass times the acceleration due to gravity. So in this case, the mass we have gotten as 24 cubic meters times 1,100, then times G, which is 10, as we can be able to see in the solution below for Roman 1. Where rho is the density of the liquid, which is 1,100. V is the volume, which is 4 by 3 by 2. Then times G, which is 10, to give us 264,000 newtons. So this is the weight of the fluid displaced, or the weight of the seawater displaced, which according to Archimede is equal to the upthrust. Therefore, we have responded to Roman 1 of the question given. For Roman 2, which is the tension on the wire. Now, the block is being pulled towards the seabed. Therefore, tension, the direction of tension is downwards in the stream. The weight of the block is also downward. Upthrust is in the upward direction. Therefore, for us to relate the three forces, that is T, W, and U, we say that tension T, capital T, plus weight W equals the upthrust. Now the question is, do we have the weight of the block? We can be able to find the weight of the block because we have been given the density of the material of the block and we have the volume of the block. The volume of the block is 24 cubic meters and the density of the block is 167 kilograms per cubic meters. So multiplying the density and the volume of the block, we get the mass of the block. Then to find the weight of the block, we take the mass of the block times the acceleration due to gravity. So in this case, it's going to be 24 cubic meters times 167 kilograms per cubic meters times 10. Then that gives us the weight of the block. Now the question is, how do we then find the tension? We say that T plus W is equal to U. Therefore, it means that T is equal to U minus W, as we can be able to see in the solution below for Roman 2. Now, our upthrust was 264,000. Then we are saying minus the weight, which is mg. And how do we find the weight? We take 0.167, convert it into kilograms per cubic meters by multiplying by the 1000. Then the volume is 24. Then times g, which is 10. And this gives us 40,080. So the tension, that means the upthrust minus the weight, gives us a tension in the stream which is 223